Hello my friends, in today's video I'm gonna try to show you how to sketch the graph of the function from the exercise number 64 given by this reflection or this definition, and then I'm gonna try to show you how to sketch the graph of the function when our power function is in the absolute value. So let me start with the first function. F of x equals negative 1 over 3 times x minus 3 brackets cubed, take away 1. So as you can see from this definition or the reflection given, our parent function will be f of x equals x to the third power. As we already know, this parent function has some kind of specific characteristics, and the first thing is that it goes through the origin of x, y plane with the coordinates 0, 0. The next important point is point 1, 1, so our function will go through this point 1, 1, and then another one very important point is negative 1, negative 1, so our function will go through these, let's say, 3 points. So if we would sketch the graph very easily, it would be something like that. So sorry, so this is our parent function. So this is our parent function, which is x cubed. Now if you want to transform this function to this definition or reflection given by this, next step you would do is f of x take away 3, which would be x take away of 3 to the power of 3. Let me show you that here we have like super special points 0, 0, then 1, 1, and next point is negative 1 and negative 1. This transformation would mean that we transform the point 0, 0 to 3, 0, because this means that we transform the whole graph of the parent function 3 points to the right. So all the x coordinates will be transformed to these new coordinates. Please have a look and note that none of the y value is being changed. The only coordinate which is changed is the x value. So negative 1 plus 3 is 2 and negative 1. So basically we can sketch the graph like this point will be transformed, as we can see here, 3 points to the right. So if this is number 3, this is our first point, and 1.1 is transformed to 4.1, and negative 1 is transformed to 0.2 and 1, which would mean that our function should look like this. I'm sorry, this is not like a very nice curve, but it would be, let's say, something like this. So this is the chart of or graph of this function. The next thing we want to apply is this negative sign, which means we multiply all the y values of our function by negative 1. So let's say or let's have a look onto this function, which is given then by this definition, I'm sorry, to the power of 3. So basically all our points, and now as this is our second transformation, we will take all these points. So point 3, 0 will be transformed 0, negative 0, it remains, so our point 3, 0 remains the same, and the next point was 1, 4 and 1, this would be transformed to 4, negative 1, and our point 2, negative 1 will be transformed to point 2 plus 1, positive 1, yeah, if you want to. So our chart would look like this. Let's have a look and let's draw the chart. This is why our xy axis here is number 3, so the point remains the same, and as we already know, this negative sign in front of the f of x means that all the values are the opposite numbers, and as we applied here this information, it would mean that this point is suddenly not a plus 1 or positive 1, but it will become negative 1. So here is our point. So this is 3, this is 4, this is 2, and let me note number 2 here, because this will be flipped from negative 1 to positive 1, and this positive 1 will be flipped to negative 1. So basically the function, I'm sorry for this, but the function will more or less look like this. So we applied now negative number for all y-axis. Let me just copy and paste this information so that we have all needed on one screen. Let me delete this one. Okay, and we start, or we continue here. So we made this transformation. Now there are like two things you can do, but I would prefer that we apply 1 over 3 multiplication, and let me explain what will happen with the function. And the easiest way how to explain is if we again take or keep in mind these 3 points. Okay, so let's have a look. So now we will have negative 1 over 3, which basically means we multiply this function by 1 over 3, but we can write it this way, and it would lead to negative 1 over 3 times x take away 3 cubed. Okay, so basically this would mean what will happen to our point 3 and 0 from here if we divide it by 3. So basically you are right, nothing will happen. 0 divided by 3 still remains 0. But if you would have 4 and negative 1, and if you would divide negative 1 by 1 over 3 or multiply 1 over 3, then you will get 0.4, because this multiplication times 1 over 3 has nothing to do with x coordinate of our point. The only thing which will change is something like this, and the last point we want to talk about this is 0.2 negative 1, and this will be transferred, or y negative 1, I'm sorry, to positive 1, because we take these coordinates, because we apply multiplication of 1 over 3 to our, let's say, like last step of the transformation. So it's gonna be like 0.2 and 1 over 3. So basically what will be the result of this is that 3.0 will remain still here, but point with the coordinate x being 4, suddenly it's not gonna be -1, but it's gonna be changed to -1/3, which is, if here is -1, closer, and it's 1/3, so it's gonna be something like that. And the same applies for x being 2, which is this point, and again here we have number 1, so 1/3 is here, and this is our new graph. But let me draw this graph again here in this part. What will happen is that instead of going through this point, we will go through this point, so the whole graph will be like behaving this way. So you can see here that all the y values are, let's say, decreased by 3 or divided by 3, so it means the whole y values are 3 times lower than in the previous function. Okay, so we did the multiplication of multiplication 1/3, or if you want to, we divided all the y values by number 3. So this is our new function, and the last thing we want to apply is take away 1. But take away 1 of all y-axis of y coordinates would mean that if we take all these 3 points, but very basically we are applying the last transformation for these 3 points, and it would mean, and I'm not sure if I'll do it properly right now, but we want to take away 1, take away 1, take away 1 from but y-axis. Okay, so what is going to happen? It means, and I'm sorry, I will delete it because I need the space. So let me go back and let me just use this part of the screen, and let me just move it up. Okay, so in the last transformation we'll do it this way. We have like our -1/3 f of x take away 3, and now we will apply take away 1 from all the y-axis or y coordinates of any point of the function, which would then mean that we will have the function given by this definition: x take away 3 cubed minus 1, which means that our point 3, 0 will be transformed to point 3, 0 take away 1 is -1, and 4 -1/3 will be transformed, as this transformation has nothing to do with the argument of the function. X value will remain, and this is gonna be like -1/3 take away 1, which if you simplify, this is like 1 take away 3, so this should be -4/3, and our last point is 2, and now it's gonna be like 1/3, which will be transformed. And again, I do repeat, this transformation has nothing to do with the x value of our point, so it will remain, and 1/3 take away 1. Take away 1 means take away 3/3, so 1 negative or -3 is -2/3. over 3. Okay, so this is like transformation of our point. And let me draw the chart or graph. Oops, I'm sorry, some technical issues. So this is our x and y axis. So point 3 still remains here. The only thing that changes, because we have the transformation like 1 unit down, so it's gonna be 1, and so it's gonna be 3 and -1, so we move the function 1 unit down, so this point is transformed like 1 point down, and the same applies for this and this point, which is in our case number 4 and -4 over 3, which is somewhere here, and the same applies here. Number 2 on the x-axis is somewhere here, and okay, let me put it here, -2 over 3, which is here. So our transformation would lead us to something like this. As you can see, the critical point which was traveling through our transformation the whole way is this point, and we started with the point at the coordinates 0, 0. Okay, now it would be nice to be really like precise, or whatever you want, to draw the chart as properly as possible. The easiest way would be to define the intercept with the y-axis. The intercept with the y-axis would mean that we are looking for the value of y when x equals 0. So from the definition of the function, it would mean that we are looking for the y if x is being 0, so y equals -1 over 3 times 0, take away 3 to the third power, take away 1. It would mean that our coordinate y is equal 1 over 3, -3 to the third power, take away 1, which would mean that this is -1 over 3 times -3 to the third power is -27, take away 1, which is -1 over 3. Okay, we can simplify it here. Negative and negative would be positive number. 3 and 27 would lead us to positive 9, take away 1 is equal to 8. Okay, so we can draw the chart very properly with these 3 points plus the intercept of y-axis, which is point with the coordinates 0 and 8. I'm sorry, 0 and 8. Okay, so let me draw the final chart, and then maybe we can also go through the properties of the function. And as I want to have everything on the screen and I want to highlight all needed information, this is my final chart. What I need is x and the y axis. So as far as I know, my point 0, is transformed to this one, so I will need 3 and -1. So this is point 3 and -1. Here the function will change from concave to convex and vice versa. Then for me the most next important point is intercept with y-axis, which is here, let's say 0, 8. So this is my next point, and as far as I was also transforming transforming the points 1 1 and -1 -1, I know that in x being 4 my value is negative 4/3, and as x being 2 my y value for x being 2 is -2/3. This is my next point, and here is the intercept with the y-axis. So I'm gonna try to do my best, but basically my function would look like would look something like that. Okay, so this is my crucial point, and now I want to compare my result with Desmos, which is the most clever idea you can do. I'm gonna use Desmos, and I'm gonna show you like really a proper graph of this function. Okay, which is this one, and if you would do it by your own using the Desmos, you'll see that we are really true, and we found really like the proper chart of the function -1/3 times x take away 3 cubed minus 1. And as this video took quite a long time, I'm done for now, though I owe you the properties of this graph, but I'm pretty sure you can find out that the domain of our function is all the real numbers, and the range of our function is also all the real numbers. You can see that it is increasing on the domain, and it is unbounded, and it has no maximum, no minimum, and what else we can say? Your most favorite, not periodic periodic function, but it is a 1-to-1 function, and dobre, je klesajúca. What else are we supposed to say? Basically, I'm pretty sure you can find all the other properties, but let me check. Is it odd function? No, not odd, not even, I'm sorry, not even function, no min, no max, done. 1-to-1, yes. Graph, cubic curve, unbounded, odd, even, done. Okay, I'm done here. Thanks for watching the video, and probably I will do another one with the absolute value, but no one knows when it is gonna